So we talked about two proportions. Now we're going to do our procedures for two means. And so it's going to be all the same ideas that we talked about with two different proportions, except now we're going to bring in the formulas and stuff for means. All right, that's what we're going to be doing. And the first thing that I want to point out here, and this part isn't even new, okay? Remember that our standard deviation is usually s sub x over square root of n. So if I have two different, if I have the difference of two means, remember if I'm subtracting two different variables, the mean of the difference is the difference of the means. And then for standard deviation, remember that I add variances. So what that's going to look like, if I have S1, S2, and N1, and N2, we're going to have S1 over square root of N1. That's our first standard deviation, squared to get the variance, plus S2 over square root of N2 squared to get our second variance. So then the total variance, if I add them together, sorry that the PowerPoint is messing with things. S sub 1 squared over square root of N1 squared is just N1. And then S sub 2 squared over square root of N2 squared is just N2. That's our variance, and then we take the square root of it to get standard deviation. So that's where the formulas that you're about to see are going to come from. It's the same idea that we did with proportions, which is adding the variances. And just like with proportions, that formula is going to be on your formula sheet. So let's take a look. It's gonna walk through this all again. There are like two new things to keep in mind, and we just talked about one of them. So it's going to be pretty simple here. So average heights, here's the thing. We're just, the main thing is, here's our subtracting the means and adding the variances. So, mean the difference is the difference of the means. There's how we get the variances. Add them together. Take square roots, get standard deviation. So shape, center, spread, and distribution looks like this. All right. So, again, I'm going to go rapid fire through this example because there's not going to be much new here. It's just going to be plugging the formulas I just showed you in. So shape, center, and spread. We have 12 girls and 8 boys, but since both populations are normal that we're pulling from, the distribution of this is going to be normal as well. If they weren't told to us that it was normal, we'd be in trouble because then we'd be less than 30. So we'd have to look at some plots. But since we're coming from normal distributions, the distribution of their difference is also going to be normal. Center, mean of the difference is the difference of the means. So we subtract these two means of 56.4 and 55.7, and that's the mean difference. Standard deviation, this standard deviation is 2.7, this standard deviation is 3.8. So again, that's subtracting the variances. And so that's what my standard deviation looks like here. Okay, that's shape, center, and spread. Yes, X sub F, female, male. 15 seconds and it's going away. What? Take a picture. It'll be on the video too. You can pause and write things down here. But that's the ideas. Any questions on that before we go on? Yes. Here's the standard deviation from here. Here's our sample sizes, right? Our standard deviation, square root of n stuff. Because whenever you're combining two different means, mean differences subtract the means, and to find standard deviation, you add variances. That's something we talked about chapter 7. We did the same thing to get the proportion formula. We added variances. Okay, so now we can take the mean difference and say, okay, I got a sample that was here. What's the probability that I get a sample that extreme? And so what you're going to see next is basically what we're going to do to calculate a p-value. And the probability that the sample is that extreme, again, it's a z-score, value minus mean over standard deviation. And that probability that we have that low a value is 0.3264. So that 0.3264 is going to say, well, that's a pretty high chance. So it doesn't give us reason to doubt the claim. Or in other words, what we're going to put it in just a second, we're going to fail to reject the null hypothesis. 15 more seconds. Again, this should all basically be review. It's doing the same thing that we started with in the first section. It's just this time we're using the mean formulas instead of the proportion formulas. I'm going so quick because I don't want to overcomplicate. I don't want to, flood you with a bunch of details that you already know. All right. Here come the formulas for hypothesis tests and confidence intervals. Here they come. The two-sample t-statistic. So now we're using t-scores. So our standard error formula, add the variances. It's on the formula sheet. Should be in the section that talks about two means, right? Difference of two means. And so, value minus our mean over our standard deviation. And since we're using t-scores, we need to talk about degrees of freedom. And our system, remember, degrees of freedom is usually n minus 1. And so we're going to play it on the safe side and use our smaller samples degrees of freedom. So on the last example, we had a sample size of 12 and a sample size of 8. So we would pick the smaller sample size of 8 and use 8 minus 1 is 7 degrees of freedom in that case. So if the two samples have different sizes, then we're going to use the smaller sample size as degrees of freedom. I think the only new thing I have to tell you is the calculator. Everything else is going to be slotting our formulas that we already know into the structure of the formula that we already know. Here comes the confidence interval formula. Guess what? The confidence interval formula is going to be our mean difference. That's going to be our statistic. Plus or minus our t-score. Again, smaller sample sizes, degrees of freedom. Times the standard deviation formula. There's the standard deviation formula.
Wait, what did you describe our mean difference as?
The statistic.
Oh, okay.
Right? Remember, confidence interval is, if you look on the first page of your formula sheet, it's labeled as that structure, statistic plus or minus critical value, it is the t-score, times standard error. And then here's your standard error formula. So you take the statistic, which is this mean difference, Usually we get a single number. We just subtract these two. And then plus or minus whatever our t-score is times there's our standard error formula. So we'll put it in there. Again, step 3 is going to be formula, plug in numbers, answer. Make sure you say your degrees of freedom since we're doing t-scores. Hey, look, it's our conditions. Random. Do they both come from random samples? Or are we splitting these into 2 different groups and assigning them randomly? Those are going to be the 2 most common ways that the random conditions are going to happen. You need to check these for both sample sizes. Normally, you need to check whether both sample sizes are at least 30. And if they're not, you need to check some of their graphs here. Independent, both populations at least 10 times sample size. So, our same conditions that we've been doing. All right. Let's do a confidence interval. Again, we're going to go fast. I want to do this in 4 minutes. Step 1. We are estimating the mean difference of dBH in centimeters of these separate samples and trees. What are the 2 different samples? It's going to be the north half of the forest and the south half of the forest. So our step 1 is going to look like this. 90% confidence interval to estimate the mean difference and define your variables. The first mean is the north end, the second mean is the south end. That's your step 1. Seconds. Step 2. Sample t interval. Not proportions anymore. It's a confidence interval, so t interval. Here come our conditions. Random. Hey, both sample sizes were 30. That's convenient for us. So that's our normal condition. Random, we took random sample of 30 trees each from both ends. Independent, these forests are big. Step 3, calculations. We're using the lower sample size degrees of freedom. Well, they're both 30, so we're going to use 30 minus 1, which is 29. As our degrees of freedom, that means our t-score is going to be 1.699. I'll show in the calculator in just a minute. "15 seconds. And then I'll show the calculator. First off, to remind you how to get the t-scores, remember that's going to be inverse t on your calculator. That's in second distribution, same place that inverse norm is, except here it's inverse t. Area to the left, 0.95, because we got the 90% in the middle, plus 5% in the tail. Degrees of freedom was 29, or 30 minus 1. And there it is. So that's how we get our t-score. Stat tests. Oh, not tests. Intervals. 2 sample t interval. Did I put data in list 1? No, I have stats to give you. Then you would put in all these means and standard deviations and sample sizes. Confidence level would be 0.9. Pooled, we're going to put no. Pooled, we're going to put no, yes. We're going to put no for pooled, and then it's going to calculate. This is around what you should get for your confidence interval. So step 4, we're going to interpret. We are 90% confident that the actual mean DVH for these trees, the difference in these means is between 3.83 and 17.83. That's our step 4. Same way that our step 4 has always looked. Here is the 10.2 homework assignment, which you should be able to get started on. We'll do all this tomorrow. There it is. I mixed and matched from different places, so it looks longer than it is.